Welcome to the deep dive. We are taking a fire hose of sources, articles, research papers, expert notes, and really just boiling it all down to the insights you need for the next wave of AI. Today, we are diving headfirst into the future. We're looking at the key trends that really defined the last year and trying to understand where the industry is pointing all of its energy as we head into 2026. Our mission is to unpack the biggest shifts from 2025. You probably remember 2025 was meant to be the year of the agent. But for a lot of us, it felt like those specialized agents we were promised were, I don't know, the dogs that didn't bark. But what our sources are saying is that actually that dog was barking. It just grew into a wolf, a system orchestrator, to be precise.
That's a perfect way to put it. The industry didn't stall at all, it pivoted. And it pivoted aggressively. We've compiled insights from some of the top tech architects, and they all point to really three connected themes. First, the evolution of those small agents into these powerful orchestrators or super agents. Second, the hidden friction in open source AI. We call it the packaging problem. And third, the critical new focus on computational efficiency. It's totally reshaping hardware and how we build models.
Okay, let's start there. Let's unpack that shift in agents, because going into 2025, the promise was you'd have an agent for travel, one for email, another for research. But that just didn't really happen for most people, did it? It was kind of overwhelming.
It was too much noise. The idea that agents were the dog that didn't bark comes from, I think, a misunderstanding of where the evolution was really heading. So the agents didn't shell. They moved up the stack. They evolved from those little specialized tools into what experts are now calling super agents, system orchestrators.
Okay, so what's the tech behind that? What was the leap that enabled that?
The leap was a massive improvement in the model's reasoning and planning capabilities. They can now do these complex multi-step thought processes, things like planning loops, tree of thought. It lets them use multiple tools in sequence. So instead of just calling tool A, the model can reason, okay, I need to call tool A, check the output against my goal, then I'll use tool B and then tool C to get this one big thing done.
And that completely changes the experience for the user, right?
Yeah.
You don't have to juggle 5 different agents anymore. You just talk to one conductor. We saw some of this emerging last year. I'm thinking of Manus, where you give it one job, like create a go-to-market strategy, and 30 minutes later, boom, an entire presentation is just done. The research, the visuals, everything.
Yeah.
You didn't have to manage any of the steps in between.
Exactly. And the big frontier AI players, ChatGPT, Claude, Gemini, they're all racing to become these super agents. They're adding connectors, tool use APIs, these Canvas features. They want to be the one system that handles the whole workflow.
It sounds like a huge reduction in friction. We went from too many agents, too many tools, to just wanting one system to handle it all. But wait. If everyone's fighting to be that one orchestrator, doesn't that just create a new kind of vendor lock-in, the very thing we were trying to avoid?
That is the central strategic risk right now, 100%. The market battle has kicked off, and it is focused entirely on controlling the front door to that super agent.
And it's not just a chat window anymore.
No, not at all. This is a platform war. We're seeing it fight out across every boundary. You've got the browser space, right? Perplexity with its Comet browser, Google baking Gemini right into Chrome.
And mobile, too. Apple extending Siri, Gemini being pushed into Android.
Exactly. Everyone is trying to take a user habit you already have, searching, coding, just using your phone, and strap the agent onto it. It's all about becoming that default entry point.
So what's the 2026 prediction here? Who wins this control battle? The browser, the OS.
I think the future is actually a layer above both of those. We're going to start seeing the maturation of what's being called the agent control plane. Think of a multi-agent dashboard. Systems like Manus or those anti-gravity concepts we've seen from Google.
So a single place to manage everything.
A single place to manage agents that are running in totally different environments. You might have one agent in your terminal, another in your code editor, a third sorting your email, and you manage them all from one central dashboard or inbox. The battle won't just be for the front door, it'll be for the control center.
Okay, so while the big proprietary companies were fighting for that front door, 2025 was also, you could argue it was the year of open source. The quality gap just kept narrowing. We saw models like Kimi K2 come out and really challenge the top tier on performance. It felt like open source was winning.
The enthusiasm is definitely warranted on the core model quality. It's incredible. But if we're being honest, if we take a sober look at the commercial reality, open source still has a fundamental packaging problem.
And what does that look like in practice? For someone who isn't a developer, what is that packaging problem?
It looks like friction. It looks like a bad user experience. Proprietary solutions give you this seamless, integrated, full software stack. I mean, think about this example. A user snaps a picture of their kid's drawing. It's just a crude sketch. And Gemini can take that, instantly render a beautiful, finished image, and embed it in a document on their phone, all in one click.
Wow.
Now, that needed a great model, yes, but it also needed a full system of guardrails, generation loops, and a perfect, stable user journey.
Right. And open source.
Open source often has amazing components, maybe even better bits and pieces for every single part of that process. But it lacks a standard way, a clean 5-minute process to pull it all together and get that same level of user joy.
Oh, I feel that. I remember trying to get that Kimi K2 model running locally. I could spend an hour just sorting out the dependencies. And suddenly the proprietary option, where I just pay an API fee and it works, that looks really, really attractive.
Exactly. Tinkering is fun for us, for hobbyists, but as one of our sources put it, that's a me problem. That is not a problem the rest of my family wants to solve.
So what's the outlook for 2026? Are we going to solve this? Will the ecosystem catch up?
I think the packaging problem is hitting a breaking point. The community knows it's an issue, and I think solutions are going to emerge. I suspect we'll see a high-quality open-source generalist agent with a full open stack, the model, the framework, the tools, probably emerge next year. It's not far off.
But will that be enough to, dethrone the closed systems?
Unlikely. And here's why. The outcome is probably going to look a lot like the history of Linux.
Okay.
Open source components will run everything in the background. They'll run all the servers, they'll underpin closed systems like Android or parts of macOS. But better, highly monetized closed solutions will still thrive because they offer that polished, guaranteed experience.
Yeah.
It's a two-sided world.
Let's shift gears to hardware, because the supply constraints in 2025 were just. They were a massive structural problem for the entire industry. We heard from experts that 2025 was the year demand outran supply, which meant companies had to start optimizing strategy around compute availability, not just model capability.
And that scarcity created this very clear hardware dichotomy that defines every strategic choice being made today. On one side, you have scale-up.
The massive clusters.
Massive clusters. Your NVIDIA H200s, B200s, Google TPUs. That's what the big frontier labs are prioritizing, maximum power. But on the other side, you have scale-out, efficiency. This is your edge, local, heterogeneous compute. Apple's NPU, Qualcomm's NPUs, and smaller LLMs like 1 to 3 billion parameters.
So efficiency, sovereignty, more control.
Exactly.
So it sounds like in 2026, the industry it has no choice.
Great.
It has to shift from scaling raw compute to scaling efficiency.
Absolutely. The prediction is that 2026 will be the year of frontier models versus efficient model classes. We just can't sustain the scaling of physical compute, the power, the cooling costs. It's insane. So the focus has to shift to these efficient model classes, from 250 million up to maybe 20 billion parameters.
We hear a lot about 4-bit quantization when we talk about running models on the edge. Can you just quickly break that down? Why is that so important for efficiency?
Sure. Think of it like compressing a huge file. When you train a model, the numbers it uses, the weights, are usually 16-bit or 32-bit, high precision. Quantization is just the process of compressing those weights down, often to 4-bit. This makes the model file 4 to 8 times smaller.
So it runs faster, uses less memory on your phone or whatever device you have.
Exactly. And that's what moves edge AI from just hype to, actual reality. Running a massive generative model on your phone is still a bit of a fantasy. But running a 10 billion parameter model locally, using 4-bit quantization and specialized hardware, that is becoming feasible. And this is supported by new architectures, like Mamba 2 hybrids, these state space models.
Let's pause there. What are state space models and why are they better for the edge?
So they're an alternative to the transformer architecture that pretty much all LLMs are based on. State space models, like Mamba, they handle sequences of data more efficiently, specifically because their computational needs scale linearly with the length of the sequence, not quadratically like transformers.
Which makes them much faster and easier to run on edge devices for long, continuous jobs.
You got it.
So this makes the hardware competition really interesting. I mean, NVIDIA is still king, but is 2026 the year their dominance really gets challenged?
The challenge is definitely going to intensify. We'll see more maturity from competitors. We'll see early ASIC-based LLM accelerators chips designed just for inference and more chiplet designs. But what's really fascinating to me is the potential rise of a totally new class of silicon, what some are calling agent processors.
Agent processors.
Yeah, agents just changed the game. Their workloads are fundamentally different from traditional AI. They're long-running, they have to be stateful, they need to remember what they did yesterday.
And they're working with all these different data streams.
Right. So these tasks need memory persistence, really fast planning loops, low latency scheduling. Traditional GPUs are built for massive parallel batch jobs. Agent processors will be optimized for fast, stateful, sequential reasoning. This is where specialized architectures, like IBM's data flow systems, could really start to shine.
And this drive for efficiency is critical because the super agents we're talking about have to process all these diverse data streams. Which brings us to our next section, multimodal modularity. Agents have to interpret the world with multiple senses, right? Vision, audio, language. It's all driving this idea of contextual computing.
The vision for the future is models moving toward neuromorphic reasoning, being able to see, hear, and read everything. Bridging language, vision, and action. This is what enables these complex digital workers that can handle, say, an intricate healthcare case, where the input is x-rays, lab reports, doctor's notes, audio clips, all at once.
Okay, so let's unpack the architecture for that.
Yeah.
Because it sounds like instead of building one giant model that does everything, the trend is toward modularity. What does that actually look like?
It's modularity through orchestration. So instead of a monolithic jack-of-all-trades model, organizations are tying together specialized models and adapters.
Things like LoRa or Aurora adapters.
Exactly. It's like a network. You have a vision adapter for images, an audio adapter for sound, a core LLM for reasoning, and you just orchestrate them with software glue.
And the benefit there is a smaller footprint, and you get to pick the best-in-class component for each specific job. So you could use a special adapter that's amazing at pulling key value pairs from dense enterprise documents, instead of a general model that might just make something up.
Precisely. And that orchestration, it also connects directly to the importance of the human in the loop, especially for those high-stakes enterprise cases.
Why is that human element still so critical, even with these super agents?
It's essential for quality control, for fine-tuning skills, for fighting hallucinations, especially when you have complex, ambiguous inputs. Take that healthcare example. An agent might be analyzing a patient's chart, which has complex tables, a really hard modality. It might misinterpret a tiny data point.
And the consequences could be huge.
Right. So the human provides targeted feedback that changes the model's attention, improving its accuracy for that specific critical task. You need the human to align the model to the exact action and make sure the reasoning process is safe and accurate.
We hear so much about consumer stuff, text to image. What are the really exciting modalities experts are focused on for enterprise use cases in 2026?
The focus is very practical. It's aimed at improving real business processes. First, complex tables and charts and documents. Second, computer use. That means models controlling screens, capturing images, the digital worker on your desktop. Third is audio. And crucially, vision embedding for R pipelines, retrieval augmented generation.
Let's pause there. For anyone who isn't deep in the weeds, what is R and what does adding vision to it do?
RAG is basically grounding an LLM in specific, trusted data like your company's documents so it doesn't make things up. Vision embedding means you can take visual data, a complex diagram, a floor plan, a screenshot, create a numerical representation of it, and store it right alongside your text.
So when the agent asks a question,
the RAG system retrieves not just relevant text, but also relevant images or charts. It gives the agent a much richer, multimodal context to work from. It makes enterprise data retrieval way more robust.
This has been a really illuminating deep dive. So if you're walking away from this, what are the 3 key trends for 2026? It seems to be the pivot to the super agent orchestrator, open source finally solving its packaging problem, and this inescapable drive for efficiency in both hardware and models.
And they are all converging. These aren't isolated trends. They are creating a systemic change that shifts the point of control and the complexity away from you, the user, and into the AI itself.
So what does this all mean for you as you get ready for 2026? The ultimate convergence point is that agent control dashboard, that single orchestrator. And the biggest question for you to consider is this. When you look at your own digital life next year, which platform, the OS, the browser, or a totally new dashboard, will you choose to manage your entire network of digital agents? Because that decision is going to redefine your digital existence. That's all the time we have for this deep dive. Thanks for tuning in, and we really encourage you to explore these concepts further. We'll see you next time.